today for this exciting session, Unlocking Machine Learning Magic with Python, organized by UPS Dehradun in collaboration with IET and NBSP as a part of the Continuous Process Development Series. I am Purvika Joshi, a final year student at UPS Dehradun and a member of UPS IET and UPS NBSP. It is indeed an honor to be a part of this gathering where we explore one of the most revolutionary technologies of our time. To begin with this event, let me first extend a warm welcome to our esteemed chief guest, Mr. R.S. Grover, Chairman at IET Delhi Local Network. His leadership and expertise have been instrumental in driving innovation and excellence in the field of technology. We are truly privileged to have it with us today. We are also delighted to have with us our special guest of honor, Mr. Narasimhan Venkatesan. His insights and contributions to the field have been invaluable, and we look forward to hear from him as well. Now, I would like to invite our special guest of honor. I would like to invite our chief guest, Mr. R.S. Grover, to share a few words with us. Mr. Grover, the stage is all yours.
Good morning, everyone,
Good morning,
particularly
sir.
Dr. Tanupuria, who has taken a lot of initiative to organize continuous process development series. And we are fortunate to have him in Dehradun. And today topic is unlocking machine learning magic with Python. And Dr. Aditya Tandon, Associate Professor, Sharda University, is going to address us on this topic. I, as Chairman of IIT, I welcome you all, including my senior colleague, Mr. Venkatesan, and Mr. Mehtab Singh. On behalf of IIT, I would like to say that the Institution of Engineering and Technology is a multidisciplinary engineering profession institution formed in the year 2006. And today we had about 1.6 lakhs membership spanning over 85 engineering disciplines. I only want to request Tanupriya and his associate that under the banner of IIT, this your banner you have taken for continuous process development series should continue. Whatever frequency you decide, we will welcome it. And with these words, once again, I welcome the speaker today, Dr. Aditya Tandon, and lot of thanks to Dr. Tanupuria. Thank you very much.
Thank you, sir. Thank you. Over to Purvika, please.
Thank you so much, sir, for those enlightening words. Next, I would like to invite our special guest of honor, Mr. Narasimha Venkatesan, to address the gathering. Sir, we eagerly wait for your thoughts.
Thank you for this invitation. Dr. Tanupriya, Mr. Aditya Tandon, Associate Professor, Sharda University, my chairman of IIT, Mr. Grover, Mr. Mehtab Singh. It's a great pleasure to attend this event because it signifies an attempt to spread knowledge. And volunteering effort goes and it requires recognition in all respects. I think with a small step taken by UPS under the guidance of Dr. Tanupriya and Shramdan given to people like Mr. Aditya Tandon, I think the knowledge is definitely will get spread in India and we'll have a young workforce of lot of competence in time to come. And India will grow and become a great economy. There's no doubt about it. Knowledge is the base of economic growth. And this small effort by UPS, by Sharda University will ever be remembered. Thank you.
Thank you so much, sir.
Thank you, sir.
Now,
Over to Purvika.
now it is my pleasure to introduce our distinguished speaker, Mr. Aditya Tandon. With a BTech from the Apex Institute and a Master's from MIT University, he is currently pursuing a PhD at Quantum University. Dr. Tandon has over a decade of teaching experience and has published more than 25 research papers in his field of expertise. the Internet of Things and data science. Additionally, he runs the popular YouTube channel See for Yourself, which has over 2 lakh subscribers. Please join us in welcoming Dr. Tandon. Now,
Welcome you, sir. Over to Aditya, sir, please. And one more point which I have missed, he is pursuing his PhD under my guidance. Thank you. Thank you for joining again.
Thank you,
now,
sir. Thank you, everyone.
thank you, sir. Without further ado, let's dive into the core of this session. And now I would like to invite Mr. Aditya Tandon to take us through the fundamentals of machine learning in Python and its transformative potential. Over to you, sir.
Sure, sure. That I'll be more than happy and delighted and honored to be there. And so in this session, we'll be discussing about basics of machine learning as well. Not the basics which you generally hear in a classroom. We'll be discussing about, first of all, the exploratory data analysis, the EDA, which is an essential part of any project you are going to do in case of any machine learning area or any deep learning area. So we'll be looking over, first of all, at EDA. What is EDA? Then we'll move over to three different projects. There'll be some regression projects and some classification projects as well. So mostly I'm interested in kind of regression. So regression seems to me much easier as compared to classification. It's my opinion. It might be in your case that the classification will be more appropriate for you. So I'll be there to help you out. And first I'll share my screen. Let me do that. Yes, my screen is not visible. Okay. Please do confirm from your end if my screen is available to you and you all see what's happening on my screen.
Yes, it's available.
Yes, sir.
Right. So first of all, I need to tell you that only 99% of the students who are interested in machine learning and deep learning, they all know only two websites to gather the data sets. The first of all is the UCI Machine Learning Repository from UCLA, right? Second thing, they know about Kaggle. But in this my Python notebook, I'll provide you these notebooks as well. I've written you can watch my video. I've listed out 10 top websites so that you can download the data sets, the real data sets, all the latest data sets coming in various fields, which you can use in your machine learning and deep learning projects as well. So do not uh, concise yourself in two websites. There are 8 more websites too. I'll put out the about it after that. So let's get ahead in case of our exploratory data analysis. So what is EDA is all about? It's about analyzing the data set and summarizing the various key insights from the data, what you can get out of that data set. So क्या आप निकाल सकते हैं data set से, what kind of meanings you can deduce, and whether those meanings are useful to you, are beneficial to you, have any kind of business sense for you. If you are running your project for some business or you are building a product to mitigate something or to solve any problem, so whether that insight is beneficial to you or not, this is the process is called EDA. So we have to understand the data set, its shape, what kind of shape is it in, how many rows, how many columns are there, the type of each column, data type of each columns, the categorical and numerical columns are as well. You have to check for any missing values. Yes, my dear learners, missing values are very harmful to any machine learning algorithm, okay, because our machine requires a full meal and do not want any gaps in between them. So we have to describe the summary of the data set also and grouping of the classification problems. So how will we do that? First of all, I'll share you this link. This link is for dataset link is there, and I'll first click on it. And if I click on it, I have this dataset data.csv. I have downloaded this dataset already. So what I'll do, first of all, I'll put here this folder icon is there. I'll upload the dataset here. So my data set is right there. This data1.csv has been because there's already another data.csv file is there on my PC. I'll just upload it. So this is called a session storage. This file will only be there as long as this session is going on. But if I end this session, this file will be removed. So if you want permanent storage of this file, you need to store it in your Google Drive, because through the Google atmosphere or universe, you have Gmail, you have Colab, you have Drive, you have Sheets, you have Docs. So various things are there. So all are controlled by Google. So Google Drive is also connected. You have to connect or mount your Google Drive to this Colab so that you can access both things simultaneously. So first of all, I need data.csv. So I'll just rename it for now, because for it, I require this one. So I'll do that. I'll rename it. So I have renamed accordingly. So then this my data set is there. Okay, what I'll do, I'll click on these three buttons are there, these 3 points are there, and I'll select copy path. So my work is done here now. So first of all, we'll import in the various dependencies. What dependencies is required? Pandas is required always. The sklearn is required, and NumPy is also required, because NumPy and pandas go hand in hand. Also, sometimes matplotlib is also required alongside NumPy. So we have here sklearn preprocessing, and we are using label encoder. I'll tell you what this label encoder does. So we have this data collection. So what data set I'm doing? I'm bringing on the data set that is the breast cancer data set. So let me paste this slash content slash data.csv. If I had done so using Google Drive, so the link to the data set will be changed to like this: my drive, content drive slash my drive, like this. My path will be little bit changed, but I'm using session storage. So by default, the path is now slash content slash this. And what the first slash means, it's the root directory. It's a root one, because Google employs the deployment of this in Linux platform, in Linux environment actually. And mind you, Linux is not an operating system, it's a kernel. So operating systems are built on the kernels, like Kali Linux is there, like Ubuntu is there. These are the operating systems, not the you can whenever it is written that Linux is an operating system, that is incorrect. Linux is a kernel, and on the kernel you build your operating systems. So we have the data set with us. Let's execute it. Ta-da! So after executing, oh PD, no, did not execute this. Okay, I'll execute the first one. So now it is done. I'll execute it once again. Now it will define what is PD here as keyword is I've used. So I've inputted my data set to my Colab. Now let's do exploratory data analysis. What to do first? We are printing the first 5 rows of the data frame. So data frame is formed. Breast underscore cancer underscore data is the name of the data frame. Next, we do so by using the head function. We have the head function, that the ID, the diagnosis, the radius, and all the parameters that are there to calculate whether the person has diabetes or not. And on the far right, we have unnamed 32, which have NaN values. We have to remove those because we don't require any not a number value. So any value which is out of the range of the attribute or any data type, it's called a not a number. Generally, the numbers which are infinite, we do the mathematics and we define infinite, right? So that if I divide anything by 0, that the number will come out to be infinite. That infinite is number nothing but NaN or not a number in case of Python. So we'll be removing those as well. So first of all, we have the diagnosis here. Diagnosis is M and benign, M and B. So malignant and benign. I'll be showing you more about this. So we have 5 rows and 33 columns because I'm showing you 5 rows, 0 to 4. So if I want to show first 10 rows, so I'll do that. I'll put in 10 here. So it will show instead of 5 and this show top 10 rows. If I want to show the last last column, last rows of this, last entries of it. So I can do that using the tail. So instead of head, I can do tail and it will show me the last 10 entries of the data set. So you can see that we have the last 10 entries. So we have total of 0 to 568. So 569 are the total number of rows, and we have 33 columns here because Python and like any other programming language, it uses the numbering from 0 as well. So we have their head, and we'll switch over to our original code, and we have done that. So that is fine. Now, what I told you before, I need to remove this unnamed 32 because it does not require the unnamed algorithm, and I will remove it simple. So how to do that? Simple, the function drop. This is the same thing which you have studied in your database management system course, the drop table command. In case of DDL, data definition language, or data manipulation language, in case of DML, you must have done that. How to drop a table, how to drop a column of a table. So we are doing the same. We are doing the columns equals to unnamed 32 and axis equals to 1. Why I've done this axis equal to 1? Because axis means the column. So 1 means the column, axis is 0 will mean the row. I have to specify this Python. I have to specify the machine that please remove the column, not the row. So axis equals to 1. And I'm doing that. I'm committing the change. And for commitment, I am saying in place equals to true to do the changes in the data set itself. So if I run this, it will change the data set already. It will change. Now, if I just print again using the head command, the first 5 rows, what will be the output here? So output will be the same, except for the last column is now removed. We have the last column fractal dimensional underscore burst. And now we see that there are 32 columns in there. And also, if you learners have studied R language, so in R language, summary tools module is used, heavily used. So Python is a very good aggregator of good things around the programming world. So Python has aggregated the summary tools from the R, and we can use the same in case of Python here as well. We can describe a data set as well. So what we have did. So first you need to install pip install using the command pip install summary tools. This is the module you can use. I've already mentioned summary tools modules for dataset description. I'll show how it will be beneficial for you to see that. So from summary tools, import df summary. We need to import the function df summary, and I've called the df summary with my data frame. So I've inputted my data, given the data frame. So please df summary, find out everything about my data set here. So I'll just run it. I've already executed the first line, so I did not need to do so after that. So you can see that how beautiful is the data set, the description of the data set coming up. So if I'll just review that, I'll just put in the settings, and I'll just change my theme from light to dark, dark to light. So you can see this everything, every variable, you can see the mean and standard deviation, mean, median, max. So IQR values also displayed here, and you can see the frequency or the distinct values of the data set. So you can see that there are 569 distinct values in case of ID. In case of diagnostics, we have B and M. So B are the benign and malignant. Benign means no danger is there. The person is not suffering from acute diabetes or not diabetic at all. And we have malignant, so that there is still some case of diabetes there, some traces of diabetes are there. So 212 people out of those 569 people have this malignant data diabetes as well. And you can see the 456 distinct values are there. And for every this, the graph is shown. This is the distribution graph. Are you guys able to see the distribution graph? Please do. It should be a dialogue, not a monologue. Okay. So please tell me, are you able to see the graph as well on the screen? If anyone can just confirm.
Yes, sir.
Okay, great. Because I'm very excited to tell you what is you must. Yeah, it's Sunday. Sunday is a fun day, and on the fun day we are learning with fun. Okay, so fun learning, and on a fun day it's a Sunday. So 522, 539 distinct values are there, and all the descriptions of all the columns or the attributes in the data set, we can find out that from. So you must write that in your notebooks as well, summary tools, and importing the df summary out of it. So we have done that. Thank you so much, my dear df summary. Now we'll move over to our conventional EDA. So first of all, we'll find that shape. I've already told you so what the shape of the data is. So I'll confirm that from a Python. It says that, dear user, you have 569 people and 32 attributes are there. And out of the 32 attributes, I must find out the target as well. We'll be seeing in more. So breastcancerdata.info is also there. And you can see from the info, you can find out that the non-null count is there. So there are no null values. Null value means missing values, my dear ones. If there are any missing values, that missing value is counted to be a null value. Okay. If it had, if another possibility, another universe, if the data set might have some missing values, so we need to remove that missing values as well. Either we fill it with a standard 0 or a 1 value, or we fill it with a median value of the whole data set also, or with the mean value of the data set. So we can either do that. There are many ways to go about it. And now what we need to do, so we need to drop the column ID because we do not
Aditya,
require ID. Yes, sir.
sorry for interruption. Just for a quick response, please make sure that while completing our session, students should understand the basic mean value and standard deviation, as because in our units, these topics are giving more weightage, only like special that standard deviation, combined mean, or somehow like that, if possible.
Sure,
Okay.
sir. I'll do that, sir. And thank you for sir bringing introducing here as well. I'll do that as well. So
Okay.
if
Thank
sir
you.
is
Please
requested
carry on.
to, yeah, mention the importance of mean, what is mean, what is standard deviation. So like I have a class of 10 students. Okay. You can see what I'm writing. My writing is so bad. So 10 students are there. So they have their marks of in a course of 100 marks. They secured, some of the 56 have secured, some have 32, some have 64, and some have 33. Some have 78, very good marks, 87, 91. I think is 4 and 3 is 7. And then we have 32, we have 47, we have 58. So we have these marks are there. So 4, 5, okay, 4 and 4, okay, 2 and 6. So these 10 marks are there. So if you calculate this, the mean out of it, the mean comes out to be what? If you do that, hurry up. I'll put up the calculator so that I can do that for much faster. So we have 56 plus 32 plus 64 plus 33 plus 78 plus 87 plus 91 plus 32 plus 47, and then final we have plus 58, and total comes out to be 578 divided by 10. Now we have the average, or you can say the mean, comes out to be 57.8. This is the mean. So in case of central tendency, this graph is displayed. I must draw this again so that you guys be able to see that clearly. Okay. So we have this. Okay, I think it's coming up on a very slanting way. I don't know why it is happening. Okay. This is the graph. So this line here is mu, that is mean. And my values are deviating from it. You can see the 56 is deviating a little bit out of this 57.8. 87 has more variation, has more deviation from my value of the mean. So this is, so my curve will be like this as well as. This is what we call a bell curve. So if you can see that there are the range of values lesser than the mean and more than the mean, right? The lesser than the mean and more than the mean, the lesser will be towards minus infinity and the more will be towards plus infinity. And you can see that these values are there. And the difference between the value and the mean part is called a standard deviation, SD. And if we collate all the standard deviations, we'll have our variance, right? So variance in the values, we square it up, because variance is on the positive side and on the negative side as well. So if we include positive and negative both, we square it up, then the variance square is known as the standard deviation. So sigma square, sigma and sigma square, right? So sigma is your standard deviation, sigma square is your variance. So this is what we do in our central tendency or statistics. So this is a measure of central tendency. We have this mean values there. So what kind of median is there? If we talk about median, so median is the median value where we divide our list in two halves. This is the median. Okay, that's you can also see that the prime meridian, the longitude goes on in the earth, and so that because of prime meridian we have Greenwich Mean Time, and on the right side we have the plus GMT plus, and on the left hand side we have GMT minus. Right, the hours are divided. So this similar concept is there in case of the time zones of the world as well. So median, and then we have mode. Mode is what? How many of this data is repeated? So 32 has come around, has occurred 2 times. The frequency of any value, the mode is of 32 is mode of every value is 1 except for 32. So this is a mode. So mean, median, and mode, you need to understand standard deviation and variance. This is the simplest explanation I could come about. If you have any good explanation, please do let me know so that I can improve my knowledge as well, my understanding as well. So I hope I have mentioned you, I have explained you this particular concept.
Thank you. Thank you.
So this is the thing. So I'll clear this board. Now we'll move over to this. So we have the columns. So I need to remove this column as well, ID, because I do not require any ID of the person or coming in, right? I do not need it. I might need, but machine doesn't need it now. So we just remove it. So I removed this column, and after removing what I did, so column has been removed, in place equals to true. If I just check it again, so it will be same. And then where the diagnosis column is a categorical column. You can see the diagnosis column. This is diagnosis column, right? The diagnosis is the categorical column. I have shown you here as well. It's a categorical. Rest all other columns are numerical columns. They have numerical values there, but only this kind of attribute is having categorical. That is, object is there. Object means string values there. The B and M are not numbers, there are strings. So what I did, what I want to do with it, I just want to value first out the missing values, find out what are the missing values there. If it confirms, it says, dear, you don't have any missing values, you're good to go. So Python says you're good to go. Yeah, do your job, do your thing. Yeah, go ahead. So as we see, the data set has no missing values. We can find out the statistical summary. I've already shown you the statistical summary. That is the DF summary part, which is the flavors of our language. This is the basic Python sklearn part of describe. We have seen that. So we move over to our simple checking the distribution of target variable. You can check also the mean and median 50th percentile are close to each other. You can see that as well. The mid value is generally the mean value in case of so the data set is good. If you can find out that the median and the mean value of any data of any column the data set is there, they are close, pretty close. So then, okay, that's good. It is good. The mid value should be a mean value as well. So it is good. The data set is very good. So you can, if anyone wants to check that whether this data set is good for my understanding, good for my project as well, you need to note it down. The mean and the median, or the 50th percentile, that the median is 50th percentile, are close to each other, should be close to each other. Okay. If you want that, I can show you that as well. I can run it and I'll show you what I mean by it. So if you can I just mentioned this one. So 50th percentile and the mean. You can see the mean value of everyone. They said this is 14.12 and this is 13.37. They're very close to each other. 18 point this, 91, 86, 654, 551. They're pretty close to each other. And most of the columns do have this things. So we move over to our diagnosis column. We need to find out the value counts. What are the value counts here? So we have, I already told you that there are B cases that is 357 and M cases that are 212. So I'll be labeling them as well. So instead of writing B or M, I'll be labeling them using a label encoder. How does the label encoder will do? Will do that. What is label encoder? It will be labeling my B or M. I'll show you what kind of thing it does. Like if you have 3 classifications, if you have 3 categories, let's say in case of buying a car, you must have this petrol, you have diesel, you have CNG, right? These 3 categories are there. So what label encoder will do, it will put numbers representing those categories. Okay, so in case of 3 categories, the numbers will be assigned to them as 0, 1 or 2. In case of only 2 types in a category, we have diagnosis. In case of diagnosis, we have B, we have M. So in case of B, it will be doing 0, and in case of M, it will be doing 1. It will be replacing at will. We can also do that without using label encoder. I'll show you another projects as well. So you can see that the label encoder does this job pretty well. Okay, I'll first remove that, what I just written. Okay, now we're good to go. So what I did, did the fit transform button. It will transform my data set, only the part of the diagnosis, not the whole data set. Okay, I need to just encode the label, give it a label, and encode it with a 0 or 1. So there will be the labels will be there stored as well. The target, it will be the target there, and the columns, I remove the columns. That is the diagnosis. First, what I did, I gave them the numbers 0 or 1, and after doing so, I've given the numbers. I've created another attribute that is called labels. Okay, labels will be there with the attribute name as target. So if I've introduced a target as well, so I can remove this diagnosis column. Okay, how will it will showing? Let me show you as well. So we have encoded diagnosis. Okay, I need to find out the diagnosis. What is key error diagnosis? If I've done something wrong, diagnosis. Okay, I'll just put it. I have not removed it, right? Yes, I have not removed it. Okay, first I need to bring or run everything from the top. Okay, then we'll have our diagnosis columns. We'll run everything. Okay, statistical summary is there. Right. Now I have this, right? This is, yeah. So we have encoded. Now we will be having it removed. After it is removed, you can see the diagnosis column is not there. And now we have the target column is there, right? On the last, we have added another row. We have appended other column, that is the target, another attribute. So we'll again check with our value counts. So we have 0 and 1. 0 is benign and M is 1. So there's slight imbalance in the data, but it is fine in this case. So the imbalance in the data should not be greater. Okay, we need to if the balance is not there in the data set, we need to standardize the using a standard scalar function as well. So we'll do that in another project as well. So we need to group by our target with the means. You can see that the target, the radius in case of benign is 12. The radius of the cells here, the texture of the cells in case of non-diabetic patients at 12. In case of diabetic, we have 17. So difference is there. You can just check out the means of this, the area of it, the concavity of this, the symmetry of this, the fractal mean as the worst case of this. So you can check out every mean value in case of this. So we have the summary. We can only see for the most features, the mean values are higher for malignant and lower for benign cases. That's what you can get the insights out of it. And we have the summary of the VDA. There are no missing values. There are all continuous numerical values are there except for the target column, and mean is slightly more than the median for most of the features. So it is right skewed. It is rightly skewed towards more. Right. What I tell you, what I do mean by right skewed, that my bell curve is like this towards the benign, towards the malignant part, towards the higher part, right? It is right skewed, but it should be actual. It should be balanced. It is not balanced, so it is to right skewed. Skewed means like I'm sitting right in front of it. I'm sitting in center, right? This is right skewed. This is left skewed. Okay, this is the thing. So my bell curve is shifted to the right, it is right skewed. If my bell curve is shifted to the left side, it is left skewed. So right skewed and left skewed is there. Tanuprasad, please do remind me if I have more time or less time. Please do remind me if I have
Yes, yes, you are
enough
having
time to
time
cover.
because today we'll be completing within 1 hour so
Sure.
that students can get the hands-on in a very basic topic. And
So
after
I'll,
that, you
yeah,
can provide them short kinds of projects or simple kind of projects so that they can work on. And later in the next month, we'll be having a second session if you agree.
sure. I'm open for it. I'll be honored to do that. We'll move over to again using the same diabetes data set. We have the
And
PMA
we
diabetes data
added
set.
one more point, what is skewness of the data, how it is rightly skewed and all, if or positive skewed, negative skewed. If you can explain these topics as well, so that a basic understanding should be done from the student side as well. Thank you.
Sure, sir. So what I did now, I have introduced the diabetes prediction. So I'll be using another type of data set. I've used, I have a Dropbox link as well. I'll just move over to the Dropbox, click on it and move over. I have this data set here and I'll just have to download this diabetes.csv. So my download is done. Diabetes, I've already downloaded it. Yes, I've already done that. So first of all, what I'll be doing, I'll be importing the data set here as well. So first, if I click on this, the runtime will be started. And now my data set is ready to upload. So it's the wording is displayed that your files are saved elsewhere. Ensure that your files are saved elsewhere. The runtime file will be deleted when this runtime is terminated. This is called a session storage. So I'll just rename it to my diabetes. Here, diabetes.csv is the file name which I require. Okay, I'll just rename it as well. So now just close this. We have a data set. Just import the dependencies. What I'm doing, I'm pre-processing. What I'm extracting from preprocessing is standard scalar because this kind of data set will be hugely imbalanced. What I'll be showing you as well the why the data set is hugely imbalanced and why we need to balance the data set prior to feeding to the machine learning algorithm. Okay, because in case of KNN, in case of KNN is k nearest neighbor, in case of support vector machine, I'll be using support vector machine here as well. So these kind of algorithms do require the data set to be balanced. What I'm trying to say, I'll just explain to you as well. So we have just quickly go overview with the model selection as well. Train test split will be there. SVM I'll be there, and for the metrics I'll be introducing the accuracy score. So we have done that with our part. We have inputted our data set as well. Now good to go. We have our data frame. So what is reader in read underscore CSV? I just put a question mark here, and on this you can find out the help section which displays what read underscore CSV is all about, what kind of parameters it requires. You can just read it from there as well. I put it in for your reference. So find out the first 5 rows, the shape of it, right? And the AI of the this Gemini is also there. So it will show that you can generate the code with diabetes dataset. It will generate the code you as well. You can also input, you can generate a new interactive sheet as well. You can do that as well. The recommended plots also. It will do that. The AI is also supporting you. So my dataset shape is there are 768 rows and 9 columns are there. So this is a very limited data set. You can find out there are multiple types of data sets in case of the same disease predictions as well. You have pregnancy score, you have glucose score, the blood pressure, the skin thickness, the insulin, the BMI, the diabetes pedigree function is there, the age and the outcome is there. Okay, the outcome is 1 or 0. We'll see that what 1 or 0 means by it. So we'll move over to our diabetes description that describe the data set. You can see the count of these and the mean is there around 3.84 and the 50% around this. So data set is balanced in case of some of the columns as well, some of the attributes. But if we look at our glucose levels, in case of this, this is the difference between the mean and the median. And after that, you can see to move over to the diabetes pedigree function, you can see that 0.47 is the mean and we have 0.37. So 0.10 difference is there. It's not huge, but it is somewhat significant as well. I'll show you what I mean by it as well. So let's find out what are the value counts of it. So non-diabetic patients are 0 and 1 means the diabetic. So 500 patients are non-diabetic and only 268 out of these 768 people are diabetic. And now I group by using the mean values. I guess bring out the means of this. So you can see that the diabetic patients have more values towards the higher side than the pregnancies, than the non-diabetic people who are having the similar attribute values. You can see that as well. And the average age was also a little bit higher as compared to the non-diabetic people. So just I have to separate the data and the labels because we need to require what labels of what the target should be there and what data should be there to find out if I want to check that whether the desired output is come towards my predicted value as well. So we have to check it as well. So first I need to drop out the column outcome, axis equals to 1 should be there, and then this X will be my data now and the Y will be the labels. So I just print it. Now I print my X as well as Y. You can see that if you can just go through it, the pregnancies value is there, somewhat 10 is there, some 6 is there, because the glucose 148 is there, 183 is there, 122. Some values are nearby, but many values are greatly displaced as well. So my data is dispersed. So in case of pedigree function as well, some of the data. So we need to standardize the data. If you can just look at, I just told you, you need to standardize the data. You can see the Y column is there, that is the outcome part. So for data standardization, we need our standard scalar function. So first we'll call out our scalar, then we'll fit our X, only the data part, not the target or the labels part. We'll be focused on the data part only, that is the X part. I'll just execute it. I'll execute it and then I've executed it. Now I'll transform and I'll now print my standardized data. So you can see that the values are somewhat similar now. Now my data is now, the data set is now standardized. So after the standardized data, we again give it to our X. The X I'll put into X is there. Please have this standardized data instead of the previous imbalanced data. So we have provided that as well. Again, we print those again for the clarity so that we have done our part correctly. Now we'll move over to our train test split. We again X train, X test, Y train, Y test. Then we have train test split. We need X and Y. The test size I put in that 20% of my total data set should be the test and the rest 80% should be the training size. Then we have stratify. You must have learned about sampling. So in case of sampling, we have stratified sampling as well. Strata means categorical. The stratify, we have categorized. So in case of benign and malignant, diabetic or non-diabetic, we have stratified the data set. We have also divided the data set as per the strata, as per non-diabetic also and diabetic also. And the random set is randomly put as 2. If you can do that, I'll put that another number you can say. Then I'll print these shapes as well. X shape and this. I'll have to just execute it as well. Then I'll print this as well. So we have X dot shape. So we have this 80% of that is now training. At 6.4 is 80% of 768 and 20%, that is 154 out of 768 is the testing data. So we have 8 columns there because instead of 9 columns, because we removed the outcome part as well. Now the data is good to go and ready to be fed to our SVM model. So kernel is used linear. There are 6 kernels you can use. So I'm using the linear kernel for simplicity for you to understand it better. So classify.fit X train, Y train. Next we have kernel equals to linear. We have a model evaluation as well. So next we find out the training prediction. Whether I have trained my students perfectly, whether I have trained my machine good enough so that it has completely understood whether I've done my part or not. Let's find out what are the training data accuracy is there. So my system has secured a percentage of 78.66%. Okay, 0.7866. This is the training prediction. Now, in order to be my model to be successful, my testing accuracy should be a little bit lower as compared to the training accuracy. If it's around equal or lower than the value of training accuracy, then I'll say that my there are no cases of overfitting or underfitting. So let's check. Let's check our theory. So I'll just print out my data test data accuracy. So I found out 77.2. Right. If I change the random state value, then these values will be changed as well. So what I'll do, I'll make a predictive system. So what I did here, I put out the values. So let's open up a data set as well. If I double click on it, my data set will open alongside it. So what I'll do, I'll just select these values, a row, okay, a tuple or a row, any row, I'll put it and I'll put it here. I'll put it here, Control B. And what I did, last column should be removed because last is your output or the outcome. I'll put my comma separated. It's a tuple here. I'm creating a tuple, comma separated, and the simple braces are there. So it's a tuple, not a list. Okay, you must know the basics of the tuple or the list or the strings or dictionaries as well. There are 5 types of data structures in core Python. So what I did, I now convert this input data as a NumPy array, and after NumPy array, I'll reshape it 1, -1. What I'll do, I'll just reshape it accordingly that only one column should be there and no other columns should be there. The only one row and no other columns. So only one row should be there and no other columns should be there created. Any this, I've just excluded any chances of creating that and another columns in case of my array. So only one the array should be there. Now what I'll do, I'll transform using the scalar function, the standard scalar, and printing the std data, and then I'll move over to the prediction part. Predict, and if prediction is 0, that is non-diabetic, and else it will be diabetic. So I know the output should be 1. I've extracted the first row. So I know that my outcome should come 1. So let's check if that is correct or not. Okay, I forgot to add comma here. Okay, I'll do that. Sorry, my dear Python. No, yes, my output has come out to be what? 1. The person is diabetic. So if my answer is there, diabetic, okay, because my data set by the SVM has produced the accuracy of 77.2%. So out of 10 iterations, I may get the answer 7 or 8 times correctly, and 2 or 3 times I may get the answer incorrect. So this is what a predictive system is all about. So we have we have now 8 minutes left to our thing. So I hope you have understood. I have more projects to show you. Like I have more projects. This is the medical insurance cost protection. I'll share this with Tanupriya sir. I'll share it with these notebooks with you, and you can share with your students and all, so that they can work upon it as well. And I've also talked out the fake news prediction also, because there are so many fake news and deep fake videos are coming up today, and we need to stop those. So these are this things you can do out on yourself. And please do check out this video. There are top 10 websites to download the latest data sets for DL and ML. So that's it for this session. I hope we'll continue in other sessions as well and bring more projects for you. There are hundreds of projects I have. You can work upon those projects. And okay, this is the thing I need to say. I've learned from my various professors and teachers, including Dr. Tanupriya sir also, that we need to learn by doing. We need to be learning by doing. So I'm also a learner of my subject, of my course, of my area, and you also a learner of your subject and course or program. So I'm in the same boat as you are, guys. So that's it for today. Thank you so much for joining. Over
Thank
to you,
you,
Tanupriya sir.
Aditya. I kindly request this video link if you can put on the chat box, so that students can directly access the same as well. And the recording I'll be sharing with you, so that you can share the same with your YouTube channel as well. And please requesting you again to please share your YouTube channel link also, so that they can understand.
Sure.
And mainly students are having some issues to download the data sets and how the data set to be worked. In the next lecture, I think if you can share few insights about this, and also like in balanced data, imbalanced data, dependent data set, independent data, how to train, test these cases, overfit, how to missing values, how to test cases. These points, if you can elaborate, it would be a great chance for us.
Yeah, I'll do
And
that, sir. I'll do that.
yeah, I'll kindly introducing you one of our good faculty, Dr. Chandramani Sharma. He is having small few queries. If you please kindly answer
Yeah,
the same.
yes, he has
Chandramani sir,
mentioned
can
a
you please
question.
unmute yourself, please?
Yeah, thank you very much. Thank you,
Thank you.
Professor Tandon. It was really a wonderful session. And the way you have explained, I don't think there are any doubts. But just, maybe a little bit of suggestion or something that you can import. You would be taking, subsequent sessions as well. So maybe a little bit about visualization, and visualization
Yes,
plays a vital role in EDA.
yes,
Uh,
yes, yes.
like, apart from taking care of this standardization and the missing values, one another thing that needs to be taken care of is dealing the outliers,
Yes, sir.
because they could be
Yes, sir.
erroneous values. So, visualization through box plot, or to find out whether
Yes, sir.
outliers are there
Yep.
or not.
Mm-hmm.
And another thing is that there was imbalance in these data sets. So you'd be covering how to deal with imbalanced data sets.
Yes.
And apart from accuracy measures, what could be the other metrics that can be used to measure the efficacy of a model trained on imbalanced data sets? So maybe a
Mm-hmm.
little bit about whether the predictions are favoring towards
Mm-hmm.
majority class or minority class. So little,
Mm-hmm.
bit of that. And it was a very nice session. You have uh, taught it so well, and you are the maestro of teaching with simplicity. I watched your
Thank you so
video
much.
few years ago for operating systems, and I shared it with my students as well. It was
Oh,
wonderful.
thank you. Thank you, sir. Thank you, sir. Hope you will be sharing
Thank you,
again and again. I'm just
Chandramani sir.
returned to C
Yes, yes,
programming.
yes, yes, yes. Yes.
Thank you, Dr. Aditya Tandon. I kindly ask if the students are having any query. Ayan and Purvika and other students, if you can have any query. Okay. It seems that there is no other query.
My learners are out of the doubts. We were discussing about outliers, and hopefully, my
All
learners are
clear.
out of doubts.
No, only faculties are listening. We are listening, and students, I think they are enjoying on the Sunday, but this would not be happen. Okay,
Ah,
whatever. I'll share the video with the students as well, so that they can run these codes on their own system. If there is having any query, Aditya, may I kindly ask you to share your email ID, please?
sure, I'll put in my email ID as well.
And these projects, if you can download and share the same, it would be a great chance for us.
I'll share it right now in the chat if you are okay with it.
Yeah, please.
Yeah, I'm just currently
Yeah,
downloading
we have
them.
received your email ID. Students, please kindly have the same.
Sure, sir.
Okay. Thank you.
Right. I'll now put it up from my attaching files. Okay.
Yes.
Right.
I think Dr. Vijit Kumar, sir, are you here?
Yes, Tanupriya sir, I'm here only.
I kindly request you. He is our program leader at AIML at UPES Dehradun. I kindly request you to please share a few words about your vote of thanks to Dr. Aditya Tandon, sir, please. Over
Yeah.
to you, Abhijit, sir.
Thank you, Tanupriya sir, for putting me in. Hello, Dr. Aditya Tandon. It's a wonderful session you have enlightened all of us with your kind words of wisdom and hands-on sessions. I would believe that our students has got benefited with this, and definitely with your shared links and all, they will take more advantage, and they will come out with some good hands-on projects and all. And Tanupriya sir, I also request you that such frequent session would be happening recurrently and more frequently, and if possible we can schedule you in person in our campus. So Tanupriya sir will coordinate you. If possible, you can sit in person. Right. So thank you, Ashish Tandon sir. Thank you. Thanks a lot. That's a wonderful session.
Thank you. For a few last words, I kindly request Mr. Venkatesan, if you please switch on your camera and unmute yourself, and please say some words to Dr. Aditya, as because we'll be having few more lectures from his side for our IET as well as for our UPS students for continuous development. Thank you. Over to Narasimhan sir, please. Hope I'm audible to you. Sir, please
Yes, you
unmute
are
yourself.
audible.
Yeah. Sir, I think you are muted. From your screen, you need to unmute.
So on the top right, you'll see the mic icon. On the top right corner of your screen, you might see that of the Teams. You might see the mic option is there. If you just click on it, and you'll be able to unmute yourself.
And maybe some network issue from his end. Thank you, Dr. Aditya sir, for your insightful lectures. And thank you, students, specifically Ayan and Purvika, to make it happen, and the other participants, and especially Abhijit sir and Chandramani sir. And from IET end, I also want to thank you, Venkatesan sir, Grover sir, and also Mehtab Singh sir as well. Thank you, all of you. And one more point just to be shared, I have shared in the chat box the link of the certificates. If the students, you can fill it so that we can share the certificates as well. And Chandramani sir, we would not know that you have joined. That is why I have told the participants to write. Don't take it otherwise, please. Thank you.
No, that's okay. That's okay. And thank you for organizing this session. And please keep this good work up. Thank you, IET, and thank you, everyone. Thank you, Professor Tandon, for taking out time on this Sunday, on this, long vacations where people are planning to go out and enjoy their vacations. You are here to, for the benefit of all of us. Thank you very much.
Thank you, sir. Aditya, sir, please note, I kindly request for the next session if we can add our points which we have discussed later from Chandramani
Sure,
sir
sure.
as well. And
I'll
also,
do that.
if your timeline, if you can tell us any free time to visit our campus, it would be great, so that we can have one day session here.
Yeah, we'll do that. Probably in the first week of September. I can be there on Friday. That will be 6th September. I can do that.
Yes. Personally, I'll discuss with you. Okay, I'm signing off, and I'll share the recording links as well. Thank you, all of you.
Sure. And also, one of the students is
Shreya,
having
I
a
think
problem
you're
to.
having some query.
Yes.
One student have raised her
Yes,
hand. Shreya, is there any query from your end?
Sure, I'm unable to access the Python notebooks.
You're able to download it as well. I think from the Teams itself, right? Because I uploaded in the chat section, only the files are there, and you just have to the three dots are there. Just click on it, and you file the download.
Yes, it's not
link is there.
downloading.
Okay, I'll share these files with Dr. Tanupriya sir as well, and he'll be sharing you in your classrooms.
Yes, that would be great. Please share, please.
Sure, sir. I'll be there. I'll be sharing you.
Okay. Thank you then. Thank you, all of you. Thank you, all faculties and students and Aditya sir. Okay, we are leaving then.
Thank you, sir.
Thank you. Okay.